Alright, welcome to the stream. Alright, so this is going to be the June 2011. I'll be going through it question by question. Let me just quickly sort out my thing. Sorting out my workspace at the moment. Let's drag it over there. Block this here. I just need to get the Markscheme as well for this. I will be starting it very soon. I just need to quickly set it up. So June 2011 Markscheme. In the description below there is the link to the actual paper itself. I have not put the Markscheme there, but I have put the general link, which links you directly to the OCR site. So June 2011, need to get that Markscheme up. Just position everything on my page, well, to one screen. Just zoom in a bit. Page display, enable scrolling. Right then, so as you can see, let's go. So this is probably going to be about an hour, 30 minutes or so. Oh, but boot file. So question 1. So this is June 2011. State when the boot file is used. At the start of the when the computer first turns on, and the purpose is to load existing files, I believe. So there we go. Let's just scroll across. So question 1A answer: while the operating system is loading, or you could have said when the computer switched on or after post. What else is no additional guidance? So the purpose is to allow the operating system to load all devices, maybe? Personal settings, that's it. So just personal settings, that is all you need to say for this. And it's just me this time, it's not... Joe is not in this as he is busy at the moment, but he might join us for the one tonight. Right, so I just was explaining through speakers. Right, so I've just got it so I can hear myself talking a lot better. So this question is about, we've done that, so explain virtual memory. So you'll say a use of backend stores allows programs to run that need more memory than is available. Use of backend stores as additional memory uses paging or swapping pages between the memory and backend store. Holds part of the program not in use. Allows larger programs to run. That's it. Any guidance? Allow use of segmentation as alternate for bullet point 3. So you could say allow segmentation. So it's a 4 marker. So use of backend store, uses paging, holds part of the program not in use. That's what I'll probably try and remember for it. But then sometimes they might say explain the purpose of the virtual machine. That was in yesterday's paper that I was going through. And then it was like, now explain what a virtual machine is. Or explain the purpose of the file allocation table. That is a way of sorting data. So way much data is way to index data. So explain the purpose. I cannot think. I do not know. A map of where files are stored in backend stores or on hard drive, provides the addresses, stores file names, stores file sizes, stores access rights, identifies free space, is updated by the operating systems when files are saved or deleted, is used by the operating system when files are accessed. Whoa, that was a 6 marker. No additional guidance. So there's 5, 6, 7, 8. There's 9 points here. So you just got to try and remember 6 of them. So a map of where files are stored in the backend store. It provides addresses. It stores the file names and file sizes. It identifies free space. It is used by the operating systems when files are accessed. Software is used to convert source code into object code. So the type of software is a translator, and then the 2 types, they probably don't really want you to say 2 types yet, but since there's only 1 marker, you just say name this type of software. So just translators, since it gives an overview. They might accept if you just say compilers. Let's see. So translator, you could have said, and accept compiler or assembler. Oh yeah, assembler, not interpreter. Oh, why isn't interpreter listed? Oh, because it converts the source code into intermediate code. Yeah, so assembler and compiler convert source code into object code. Source code, so you'll probably say human readable, cannot be executed by the computer, and it cannot be done. So let's have a look. The original code written by the programmer, often in a high-level language, may be in assembly language. Source code can be understood by people, but cannot be executed until translated. Yeah, so explain the term source code. The original code, which is in a high-level language, it may be in assembly language as well. The source code can be understood by people, but cannot be executed, and you could add in until translated. Although it is in brackets, sometimes it might not be in brackets. They might actually want you to include that. Oh, yippee. Table. I prefer these kind of questions, sort of. So, complete this table. Which stages in any events occur when compiler is used? So, optimization occurs. That is within the code generation. It's on the next page, isn't it? So, I'm just going to go through. So, optimization, then code generation. So, let's compare to see if that's correct. Oh, that's quite big. Can I zoom out without... Oh, no. Sorry, I just gave away everything. Oh, I accidentally clicked share. Let's zoom in a bit more. Now let's scroll down. So yeah, that is optimization occurs during code generation. Logical errors are detected within... Logical errors... Isn't that electrical? Oh no, not during compilation. Oh yeah, because it's... Yeah, not during compilation at all. Yeah. The logical errors, because logical errors... So, from F452, you'll probably remember the different types of error... the types of error checking. So there's the runtime error, the logical, and then the syntax error. Syntax, that is just the it checks against the rules of the program. Logical, that is if you spelt something wrong, so like a variable name or something that you've created yourself. Then the runtime error is, say if you've got a loop and it keeps running, it keeps sucking more resources or so. I think that's it anyway. So logical error is detected. That is not during compilation. Tokens are created within... I'm tempted to say let's call. Yep, let's call. and then spaces are removed in electrical. So are comments, I believe. Yeah, comments are removed as well. And then that's when incorrect punctuation is detected within syntax analysis. So sorry that I actually showed that before. I'm sorry about that. Oh, great. 8 marker next. So when producing programs, library routines may be used. Explain why library routines help the programmer, and describe how library routines are used. So it helps the programmer as they are already tested so that they are error-free. Let's actually write them down. So, didn't mean to do that. Yeah, using my tablet for this. So let's just shrink that down a bit. So let's go to So what was I saying? So error-free. I'll say that error-free. Wow, you can not really read that much, but oh well. I'm just doing it in notes for now. But you'll probably, since it's quality of written language, you have to do it in full sentences. But try and make sure you include everything else. So, when producing programs like machines, explain library machines, so error-free, can be written, can be written in different languages, and it can, so error-free, different languages, save time. And then describe how they are used. That would be the programmer can call upon them, or so, I believe. So, what's that? Yeah, let's do it in a different color. So, pro can call them. This is just saying like notes for me, so I can see, because my memory is not that great, so I can't exactly. Because I don't really want to write it down. I just want to do it this way. So, candidate explains why library routines help the programmer. Let's get to the actual main points. Here we go. Here's the points. Any additional guidance? No. So the points are, keep forgetting to exit Steam before I do the streams. So points may include library routines. Oh yeah, you've got to say exactly what it is. So there are routines of piece of software which perform common tasks. Why routines are compiled. Oh yeah, this is how they help the programmer instead. I was doing like why. Oh yeah, why. I was doing why, but then I didn't exactly explain what it is. So you have to explain what a library routine is, then explain what it can be, then explain why it helps programmers. So error-free, already available, can be used multiple times, written in different source code languages. So there you go, that's the thing about saves time. And then how they can be reused. So what you need to know from these kind of things. So explain why, and then how they then describe it. So you've got to say what they are, then explain why they can help like the programmer. So then how they are used. So linkers are used, and that's linkers and loaders. Completely forgot about that. Because the video that I did for the 3 L's and an A, the 3 L's are the linker, loader, library routines, and then the A was the assembler. Right, let's go into a new page for this. If you're wondering what I'm using, TeamViewer, you might already recognise the symbol, but I'm using TeamViewer to connect to my tablet. So my tablet's on my lap, I'm just connected to it this way. So I'm using Microsoft OneNote, well, Microsoft Office OneNote, just to easily draw the stuff. Oh, 3A. Describe the effects of the fetch execute cycle on the program counter and the memory address register. Ooh, this came up in a paper that I did yesterday, the June 2010 paper. So, describe the effect of the fetch execute cycle. So you will say the address part, the PC holds the address part of the data. The address is then passed to the MAR. The PC is incremented by 1. Then you're going to have to talk about the other stuff maybe. So the data part of the instruction is given to the MDR. Let's have a look. So PC holds the address of the next instruction. I kind of talked about that. Oh, there you go. I just unveiled it all. So PC holds the address. Wait, can I just... good. I can use my arrow keys. That's a lot better then. So PC holds the address of the next instruction. PC passes this address to the MAR, and the MAR is the memory address register. PC program counter. So MAR holds the address of the instruction. The instruction from address is in MAR is loaded into MDR, so you would include that. The PC is incremented after that stage. Then the PC is changed when there is a jump instruction. Oh yeah. The way I'm actually doing these is that the papers that I've done. So the paper that I did yesterday, the June 2010 and January 2011. I've still got to do Jan 2011, but what I do is I go through it, go through the paper, then I do the paper the next day, so I can see how much I remember. I know it's probably not that great, but you should probably see, because in the previous video I showed you what I got when I redid the previous paper. State 3 features of complex instruction set. 3 features. Ooh. Difficult to program? No, that'd be a disadvantage. So 3 features. It's not a bug, it's a feature. Anyway, so 3 features. I have no idea. So let's have a look. Well, I didn't even realise that. So uses complex instructions. So basically just complex instructions. I completely forgot about that. Wow. So uses complex instructions, each of which may take multiple cycles. Single register set. Instructions have a variable format. Many instructions are available. Many addressing modes are available. And that's it. Any additional guidance? No. So it's a 3 marker, so 3 features. So I'll try and remember. The uses complex instructions. Uses complex instructions, each of which may take multiple cycles. It is a single instruction set, a single register set. Many instructions are available. So those would be the 3. So this one here, and there's a lot. Can I do control? No, I cannot. Ooh. Oopsie daisy. You did not see that. So explain one disadvantage other than cost of the CISC architecture compared with a roost instruction set. So reduced instruction set. Other than cost, so it can take many machine cycles. Is that program runs more slowly due to the more complicated instructions? I keep reading the next answer. I still haven't sorted that out. And absolutely no one is watching this, I believe. Let's have a look. Nope, absolutely no one. Oh well. This is just limited amount of editing for me, because I've got to focus on the revision stuff. So, explain one advantage. So, the program runs more slowly due to the more complicated instructions. So that's 2 marks. So you have to get exactly what they said there, and there is no additional guidance. Oh, convert this number. Thinking that my tablet might run out of battery soon. Because it doesn't like being charged by the computer thing, because that only outputs like 1.5 amps or so, and this requires 2 amps to be charged. Alright, so 4 bits convert this floating point, so binary to denary. And it's floating point, so using 4 bits for the mantissa, 4 bits for the exponent. These numbers are normalized, so let's do this. So it goes minus, I'm not even typing, wow. So it goes -1, a half, a quarter, 8th, 16th. Wait, it's only, do not include the 16th, because it's only 4 bits for the mantissa and 4 bits for exponent, so it goes -8, 4, 2, 1, so 0, 1, 1, 0, and then 0, 0, 1, 0. So let's do this. So you do half of, yeah, I've got my calculator, so I'm going to do it on my calculator. So just add all those together. Isn't that 8? What was that? 9 over something, maybe? It's been a while since I've done this kind of stuff in my head. Plus 1. Oh, I forgot to, 4 equals 3 over 4. Wow. Yeah, because it's the adding the 2 values, so it's equals 3 over 4. So it is 0.75. But if you leave it as a fraction, so then you have to do the times 2 to the power of 2. So times 2 to the power of 2, it gives us the answer 3. I'm just going to circle that. So let's have a look. So exponent is 2. Yeah, that's what I've got there. With it, so positive 3, yes. FT is what? I don't know what that means. FT if exponent incorrect. Final something maybe? I don't know. Alright, so next one, convert the next thing. I think I've got the converting down, but it's good just to refresh my memory. So there's -1, a half. I just remember the -1 as being like, if it has a 1 underneath it, it's true. If it's 0, it's false. For being minus. So then -8, 4, 2, 1. Forgot the minus. Then make sure I've copied the right one down. So 0, 1, 1, 0, 0, 1. Then 0, 0, 0, 1. Then you've got convert to denary, so it's -1, so it's going to be a negative number. Wait, I've just put it down wrong. Have I just put it down wrong? So minus... I think I may have actually copied this down wrong. What did I do before? I did do -1 again. So it's like minus. Let me do it like this. Minus. I think I may have done something wrong because this looks wrong. And it's times 2 to the power of 1, which will give you minus 1.75. This just looks wrong in the method that I've done it. Equals 1, yeah. Yeah, no. It just looks wrong. Value is minus 2 plus what? Where's it getting the 1 over? Oh yeah, because that can be related down to. Oh, I've got this right answer, so derivative value is minus 2 plus a quarter, which is minus 1/3/4, or yeah, minus 1/3/4. That's what I've got. If minus. Yeah, so I don't know. My method works, so I'm just going to keep to it. Explain what happens when the generate number positive 5¼ is converted to a normalized floating point binary number. Oh, this is when you. So you're gonna have to. You might have to write it down, won't you? Since the exponent when it needs to be normalized, you lose. It just becomes 5. So I'm not if you're sure. You'll probably have to write it down. So let's have a look. So, alright. So they wanted you to translate it. They wanted you to do it into the normalized form. So it would be. So, although you've already got the answer there, so this could just be some guidance. So 1, 2, 4, 8. So what? 0, 0, 1. Yes, 0, 0, 1. And then the half, the quarter, the eighth, and then the 16th. Because it's 4 bits for the mantissa, 4 bits for exponent. So that's 0, 1, 0, 0. And then that's going to be the mantissa, so 1, 0, 1, 0, 1. But only 4 bits allowed, so that would be lost. So it would only, so 5, oop, I don't look at 5, oop, good. Yeah, so that gets removed, so then only 5 is stored. Then, so the value is inaccurate, so the precision, so yeah, accuracy is lost, you could have said, so then you'll have to do the they wanted you to calculate the exponent, so the dot moves 3 spaces, so 1, 2, 3, it moves. Since it's a positive number, it starts with 0, 1. So it would be minus 8, 4, 2, 1, and it's 3 spaces, so 0, 0, 1, 1. So then you have to write it out. Yeah, they want you to write it out. As you see there, they want you to. The number would be stored as. Yeah, so full mark. So you've got to convert it. Then say that 5 bits are stored. So the mantissa would be that. So you've got to convert it. Then you've got to normalize it. Then you've got to say the value stored is inaccurate. Then the exponent. Say what the exponent is, and then say the value is stored by that. Describe how an insertion sort is used to arrange the following set of numbers. An insertion sort, now when it's picks that number, it compares it to the next number. If it is higher, it moves up one. No, if it's higher, they swap places. So if 17's higher than 2, so 2 would go where 17 is now. So then 17 is then compared against 3, so the pointer is incremented, and then the so pointer is incremented, so it's now pointing to 3. 17 is then compared to 3. 13 is high. 17 is higher than 3, so they are swapped. Then 17 is then, so pointer is incremented. 17 is then compared against. Well, this is repeated until all until all values are in their exact place. Well, until 17 is in the correct space. So it goes to 26, so it stays where it is, and then it moves on to 5, or does it just stop at 26, I wonder? Let's have a look. Let's use the arrow keys instead. So marks for, is there an alternative way? Last word dependent on 2 rows. Oh, they wanted you to do it in like this way. Insert 17, insert 2, then insert 3, insert 26, no change, insert 5. So list of sorted numbers is built up with one number at the time being inserted into correct position. I need to do more of the insertion sorting area, so I'm going to make a note of that with stuff I need to do. So sorting. It'd be good if my pen could work. I can't spell sorting. There we go. Sorting. It's strange that you probably did actually hear the pen hit the table then. One feature of a quick sort which is not used in an insertion sort. One feature. Use of a pivot, maybe. Set of numbers broken multiple sets. Oh, uses pivots, yay. Any more? No. Multiple is essential. So set of numbers broken into multiple sets. Or you could have said uses pivots. This is a step needed to pop a data item from a stacked data structure. So pop is removing data. So when you want to add data, let's see if that question asked. No, there's no question on that. So when you want to remove data, first of all you need to check to see if the stack is not empty. If it is empty, you report an error. Else, you remove data which is pointed to by the pointer, and then you move pointer down. You decrement, just move pointer down. Let's see. If stack is empty, so check to see if stack is empty. Report error and stop. I said report error. You've got to say report error and stop. Well, we'll see. Item in bracket shows position of data. So output data. So where the stack. So need to pop data. So yeah, remove it data so you can read it and all. Not actually delete the data or so. It could be delete. So output data. So where the stack pointer is. Decrement the stack pointer. They do actually want decrement. So the steps are that you need to check to see if the stack is empty. If it is empty, you need to report an error and stop. Else, output the data at the location of stack pointer. Well, of the pointer. Then decrement the pointer. So it would be good just to include stack pointer. Ooh, wrong one. Oh, here we go. UML class diagrams. State where the classes car and moped should go. Give reason. You may draw on the diagrams. So let me just. Where's this tool? There we go. Let's just copy it. Use a snipper and copy it. Then let's go into a new slide onto this page and just paste it in and make it nice and big, just so I can do that. And let's drag it to the center a bit more. Here we go. Alright, so now let's use my tablet. So if I just switch to my tablet view, switch to pen. Let's rotate it quickly over. Ooh, how's the battery doing? 25%. Yeah, I need to plug it in soon. We're only about halfway through or so, and we've been streaming for roughly 30 minutes or so. Alright, so car moped, so there'll be the car. They might just want it on the other side, but I'm just going to do it this way instead. So car and moped. Now this data, so just give some space for that stuff. Is it going to say it needs some stuff? No, it doesn't say. So it just says the classes, so it needs to be just added to this. I'm just going to move that down a bit actually. Get the eraser. There we go. So the reason would be that it is inherited. So let's have a look. At the same level as lorry, yep. As they are a superclass of vehicle. Oh, so they wanted you to explain it a bit more. Properties from vehicle. Accept diagram, correct errors to show inheritance from 4-second mark. So yeah. So if you draw the diagram, then just say property. So as in the same class. So inherited properties from vehicle. Registration number should be stored. State which class. So as it's going to be inherited. So moped, lorry and car inherit stuff from vehicle, it's going to be in vehicle, because you don't exactly want it to be in lorry, because, well, everything has a registration number. So yeah, let's see, so vehicle, as it's the superclass. Any additional? Nope, no additional. A company sells used cars. Part of the class diagram for used car is shown. One method, so the operation. So if you remember, show on the diagram. So do you want the X, Y and all that? Or they're going to state one method. So they're going to say they want the set price, as these are the operations and these are the attributes here. So one method would be set price, and one attribute would be model. Let's have a look. So set price or change status, and then the attribute would be either model, engine, type, or price, or status. State in which section of the diagram the year of manufacture should be shown, X, Y, or Z. So X is actually the class name, Y is the attributes, and method, well, Z is the operations. So it would have to be, since year of manufacture, that is a attribute, so it would be in Y. So I'll say Y. Why? Why is it in Y? Because it's an attribute. Oh, yeah, so the types of diagrams, so I'm just going to make a note of that as well. So types, diagrams. So this is very. So this is a. I did see it, but I've forgotten it already. So I think it's a case diagram, maybe case diagram. Oh, state diagram. Wow, I got that completely wrong. Except state only, since it's state. So oh yeah, because it's a state, because it's available for sale, and then deposit is made and it's being sold. So it's a state, so different states. Oh, I get it now a bit more. Let's see if I remember it though. So available for sale, that is a state, and then another state is being sold. So yeah, state diagram. The meaning of the symbol, the circle without the X, is the entry point. Oh, good. I keep getting state diagram, entry point, and then the X is the exit point. State the purpose of the syntax diagram. Show syntax diagram. The purpose to allow the client and analyst and programmer to understand the system easier, maybe? Is that it? 'Cause it sounds to define terms unambiguously. I keep forgetting that. So what you should remember from von Neumann and syntax is, well, give the correct name for another notation that can be used instead of syntax, and that is von Neumann. Not von Neumann. Back newest form. Von Neumann. Oh, I just said von Neumann architecture when it's meant to be von Neumann architecture, but what this answer is backness newer form. Remember, try not. Although it doesn't say, please do not use. They do accept BNF, but just if it did say do not use abbreviations, then you have to actually say what it stands for. Syntax diagram. Oh, good, I forgot that. Draw a complete set of syntax diagrams to show labels. And then it's going to be there. So we've got quite a lot of questions left. I need to know. Let's go new page. Make sure it's on. There we go. Oh, I'm just going to quickly have a drink. So, remember you can always have a go at this, or these. Oh, hello, Lewis. How are you? And that is a long delay. Yeah, let's go to it. Let's actually comment on these videos instead. Oh, that's not. Make sure. Right, so syntax diagram. So I'm pretty much doing what we do in lessons with our teacher at the moment. Yes, I know. So syntax diagram, label. Oh, the syntax. Yeah, a bit of a pain because so labels. So let me just draw these. So labels, letters. So I'm going to do letter. So that is the label. Just remember that they are sequences. You are creating something based on the rules given. Yeah. So syntax, that's when you draw everything. Well, so you've got the line that goes in like that. So arrow, line, you've got A, just make sure it has the circles as well. B and C and D and E. And then you've got the arrow going out of the system. Now you've got to do the digits, so digits, and you've got to do the arrow for that as well. So it goes from 0 to what? So that's going to be a bit of pain. There we go. So 0, 1, 2. I don't look at 2, 3, 4, 6, 7, 8. One out of space. Let's draw circles. And the reason why you need the arrows is to show that, because if the arrows weren't there, you'll just go straight through, and then that means you can have more numbers. So it's like a decision. You hit a wall and you've got to make a decision. And then I have to do it down here, the actual thing. So down here I'm actually going to do thing. So for example, A star. So it's going to be the letter. Then it's going to be the star in a circle. Then, so as you notice, A star, so it can have a digit, and it can also not have a digit, so it can have many digits. So it can have no digits, or it can have many digits. So what you're going to do, you're going to have to include a loop. Ooh, let's remove that, because you do not mean it does not connect to that. Something you should remember, make sure you actually have enough room. Yeah, so make arrow there. So then you have the arrow going back there, so that is where digits are. And that goes back into there, so that creates a loop. Let's have a look. Let's actually click on the page itself. Let's zoom out a bit then. Let's zoom in a bit. So they just wanted letter. I just did. So make sure you read the question correctly, where it says the letters. It said digits, but it's put digit. Oh yeah, because it can have. Yeah, but it's one. I don't know. So make sure you label them correctly. Do they have any additional? So a label is. Oh, so they didn't. Yeah, so arrow goes into there. Letter, then the star, and then it's the loop. Oh, I forgot to include the arrow there. Right there, I forgot to include the arrow. Oh, OneNote to stop responding. So there you go. That is to make it right. I've had to add in the arrow just so it shows where it gets added in. Let's see what you get marked for. There we go. So all 5 marks for completed, except so correct circle use of circles and rectangles in diagrams. Let me zoom out. Yeah. Actually, I've got an idea. Lewis, check your Skype. If you're online. You're not online. Right, so you get awarded for... Oop. Let's zoom into that. So awarded for the correct circles, define A to E, define digits 0 to 9, then letter, star, then digit in order with no extra terms, correct position of loop around digit. So yeah, I was gonna send you a message, like, because I've been doing some like Skype streams with some people, well, with one person even, where we just talk about this. He gets a live view of my screen while in the call, and he talks about it. So if you wanted to, so if it said not to include that, so it cannot be a star, it must have a digit or more digits, then the digits will be on the line there. Right. Hello. Right. Right. I just need to quickly change some audio settings, because that isn't working. Now the stream can hear you.
Right, okay.
And I'll just share my screen so you can see exactly, with limited delay.
Yeah. Just Skype. Yeah. Oh yeah, I can see it now. Yeah.
This is what we're actually doing in the computing classes at the moment, just going through each past paper.
Yeah.
Right. So are you all okay with these syntax diagrams?
Yeah. I was following that through, and you did the expected outcome, so that was good.
What's the next question? How are you on the binary trees?
Binary trees. So look, okay, I think. Oh yeah, the binary. Oh yeah, these are. Yeah.
Yeah, so state one advantage of reverse Polish notation compared with the usual infix algebraic notation.
One advantage.
Yeah, of reverse Polish compared with the usual infix. I've completely forgotten about that.
Yeah, I don't know. What was the advantage?
It's probably does not include brackets, maybe, or something. An expression can
Oh
be
yeah, yeah.
no rule of precision, so no brackets are needed, so it's unambiguous.
Yeah. It's something to do with like parentheses, isn't it, or something?
Yeah, it's like the BODMAS or something.
Yeah. Was that what? That is BI. Yeah, okay.
Yeah, BIC. I'm just going to quickly copy that into my notepad.
Any expression can be processed in order. I suppose that is an advantage. They're quite easy to solve as well.
Yeah, do you remember how to solve them?
Yep. I'm just getting the page.
So do you want to talk through it?
So yeah, to solve this one, you work from the left and follow it up from the right. Follow it up to the right until you basically reach a dead end. So I think this one goes PQ plus, because we go from P and then we go around to Q.
Pen.
Plus is at the top.
Yeah, so it goes down like that.
And then we're following it
And then it goes to
all the way around to R, because at the moment we can pass by the star. So PQ plus RS, and then we go back up towards the middle, which is minus, then star. I think that's it.
Yes. Start.
You start from the left, work your way around from the right. So start from P.
Yes. Let's make sure I
work your
don't
way-
actually reveal the next answer. So, yep, PQ plus R. Oh, I forgot to include the S.
Plus RS, yeah, minus star.
Yeah, forgot to include the S. Yeah. Can you give the correct name for this type of tree traversal?
I don't know, like order, something like that.
It's something order, yes.
Is it post order?
Yes, it is post order.
There we are.
Because pre-order is when you think it's right when you put it onto the tree.
Alright. Right.
Describe two differences between machine code and assembly language.
Oh, right, okay. So, machine code is low-level code, which means the computer will understand directly. Assembly language. Assembly language is code that needs to be translated for the machine to understand. Although it does relate closely to
Yeah,
machine.
otherwise, like say, assembly language is produced by the assembler. Probably like includes how they are produced as well.
Yeah, so input outputs.
Yeah,
So
machine code that is just binary, which can be read by the machine.
binary notation. Yeah.
Yeah, binary notation. Get the word in exactly. Let's have a look. Machine code written in binary or hexadecimal. No translation needed. It's then very difficult to write. Assembly
That's not-
language includes mnemonics, includes names for data stores, translated by an assembler, easier to write than machine code, but more difficult than high-level language. So
That is such
get
a
two
BS
of
question.
those. Yeah, so two differences. So try and remember for machine code written in binary and no translation needed. Then assembly language includes mnemonics and translated by an assembler. That's what I'll try and remember.
Yeah.
Explain the
Yeah.
use of an operand in an assembly language instruction. Do you remember what the difference between an opcode and operand is?
Opcode is the function that it's doing, so plus, minus, times, divide, whatever. And the operand is the data to be manipulated almost. So it's like the address field, and it like holds data.
Yeah, so how would the operand be used in assembly language?
Or it would hold the address of the data to be used. To be used by the operation given by the opcode.
I say it's been manipulated by the opcode. Address
Yeah.
field, it holds
And then
data to be used by the operation given in by the opcode, and then you get an example.
the example is that the last markers.
Yeah,
Right.
so add 12. The 12 is the operand, as it's the data part.
Yeah, so examples, that's another way of getting marks.
Yeah. Describe. Oh, how are you in the addressing part?
Describe addressing it in the. Oh god, I've not done this for a long
Direct
time.
and indirect addressing. Make the clear
Okay.
differences between them.
So direct addressing is where the address is stored exactly where the operand says it is. Indirect addressing is where the operand holds the address of the data. So yeah, it will hold the address of the data to be found.
And it doesn't it use like an accumulator as well?
I can't remember. I know that one of them is like literally it gives you where it is, and one of them gives you the address of where it is.
Yeah, I think where it is direct, and then the address of where
Of
it
where
is
it is, yeah,
the
is
indirect.
indirect.
Let's have a look.
So let's see what the other marks are for that.
So direct, the simplest, most. Oh, they wanted it to be describe it. Then the differences.
Okay,
So the simplest or most common method of addressing uses the data in the address field without modification. An example, so yeah, once again they wanted an example. So add 23, use the number stored in address 23 for instruction, and limits the memory locations that can be addressed. Index addressing uses the address field as a vector or pointer to the address to be used to access library routines, and the example would be add 23. If address 23 stores 45, address 45 holds the number to be used, then you can do any example. Increase the memory location that can be addressed, so more memory locations. Yeah, so direct limits the memory locations, indirect increases it.
right, okay. Right. Uses the address field as a pointer, and that's quite a...
Yeah, but it says in the additional guidance, it says allow only one of these. So I think it's only talk about like one direct, then talk about indirect as well.
Alright. Oh, right, yeah. Yeah, but that's referring to the last bullet points on both of them.
Oh, database management system. Use of data description language and the data manipulation language. Each statement given below may apply to a DDL and DML or both. Tick one box in each row to show which is in correct order.
Okay, so a database management system.
Let's copy
Right.
that to my note.
So we've got DDL, data description language, and a data manipulation language. Give below. So
Let's copy this.
okay, I'm gonna say that the first one is DML only.
DML only, okay.
Yeah.
Defines a phone key.
I'm gonna say that that is down to. I'm gonna say it's both of them.
Both. Okay.
No, DDL only because it's describing it. DML is where you manipulate data, and creating foreign keys is not really manipulation; it's just implementation.
Yes. So think, define, then declare.
Yeah, it can query data.
That's
Probably both.
yes.
I don't know.
Maybe we can compare this to the answers. So it can be sorted data into an order. I think that's manipulation because it's sorting. Used to update the data. Which one do you reckon that one is?
DML. That's manipulation. It is in a high level language. That's probably both of them, and it's right for using the schema. I can't remember what that was. It's like the something, but it's probably
Yeah, probably
DDL.
DML.
Just,
I think that. What do you think of?
DDL because it's describing something.
Nice. So you think it is DDL? I think it's DML. It's you is correct.
Right.
So we got the first one wrong.
DDL makes new tables and defines foreign keys.
It can be can query data is DML. So we got that wrong. Are you still with us?
Yeah.
Just because you went extremely quiet. Alright, so can query data is DML only. And we got that wrong. It can sort data into an order. We got that correct.
That's good.
It is used to update data, so DML. So we got that correct again. High level language, that is both. We got that correct. Is used to write in schemes, DDL. So you were correct.
Yeah, well, I'll look at what the schema is.
Does it say... No, don't say anything.
It's the database design produced by the DDL.
Where's... a school uses relationship database. Information is stored about students and subjects. State the relationship between students and subjects. Tables. So the entity relationships. So do you remember what these are?
Relational databases, right.
What ones can you remember?
Oh, right, okay, so many to many. But it can't be that. It is many to many, isn't it?
Yeah, it's many to many.
Yeah. Explain the consequences, that's where you solve the issue around that. Because it can't be many to many. You have to make a bridge called student subject. And then make it a one to many and a many to one relationship between student subject one to many, and then many to one between student subject and subject.
Yeah, one of the keywords that I probably want you to say is it is not in normalized form, or not in third normalized form.
Yeah, 3NF.
So not allowed, not in third normalized form. Needs another table between student and subject to avoid duplication of data. So they don't really want you to say how you'll fix. Well, they don't want to say how you'll fix it if you draw it, but you need to say it needs another table to avoid data duplication.
Right, okay. Data duplication, right.
So it says you can accept not normalized as well.
Yeah, but that's the easiest thing to write about, isn't it? It's not normalized. So we'll stick with that. Yeah, not allowed in 3NF, needs another table to avoid duplication. Right.
Yeah, so there's no
Few marks.
also there's like no data redundancy and stuff like that. Inconsistencies.
Then the next question, the relationship between student and personal tutor is shown as an ER diagram.
So that's let's try and say it exactly the same time, ready? The type of the relationship shown.
Many to one.
Yep. Yeah, so explain the use of primary and foreign keys for student and personal tutor. So
Okay.
they probably want you to say what a primary key is and then what a foreign key is.
Okay, so let's go for this. A primary key would exist on both tables, and it is the unique identifier for each entity within the table. A foreign key is used when the two tables are merged into a new entity to I don't know how to describe this Markscheme way. But what have I got?
Foreign key relates to a primary key within another table.
Another table. Yeah, that's it. Yeah. Yeah.
So let's see.
Let's have a look what we got for that.
So many to one. Both tables have their own primary key, which is a unique identifier. Primary key for personal tutor is used as a attribute. That's what we need to include, attribute. Attribute in student is a foreign key in student.
Yeah.
And used to create the relationship or link between tables. And that's it.
Yeah, so that's what we got there. Both tables have their own primary key, which is a unique identifier. We said that. Primary key for personal tutor is used as an attribute. Yeah, there's that keyword again. This is a foreign key in student used to create a relationship link between tables. Right.
Yeah, used to create the relationship, or you could have said link between tables.
Yeah. Okay.
State the meaning of the term secondary key and give an example of the use of a secondary key in the school database described. Secondary key. Talking about linking again, maybe.
Yeah, maybe I can't remember secondary keys. Who knows? State the meaning of secondary key. Give an example. Let's go with it.
Oh yeah, didn't see that. I said give an example. So what would be the example as a secondary key?
Um, maybe something to do with searching.
Maybe like their student ID or something. Oh yeah, you just said sorting, and that trick sank within my head. So the secondary key is to do with the sorting methods. So it allows the user to sort between data, like create an order of the data. Let's have a look. The meaning as an attribute that can be used to search for a group of records or allow records to be accessed in a different order. Example, search for tutor ID in student to find all students with a particular personal tutor. And then another example you could have given would be student's surname in student can be accessed. Access students in alphabetical order. And that's all you'll get for that.
Right. Next question is...
And it's the last question. So relationship databases can be used to produce reports. Explain the term report and state 2 features other than report layouts included in a report definition. I think this is when they want you to talk about users can get the information that they want and they do not need specialist knowledge or so. So what what features would you give
for in a report?
So explain the term report and state 2 features other than report layout.
I don't know, a summary of the search, a summary of a given search.
A report is more like the outcome. So let's have a look. So presentation of selected data, usually in the form of a table, may be defined.
So it says in the question, other than report layout, and in the Markscheme says, presentation of selected data in a table and specific layout.
I think report layout means you've got the title at the top of like the table name, and then you've got a space for the table.
Well, it like tells you not to do something and then does it. Markschemes.
Yeah. So presentation of selected data, usually in the form of a table, may be defined in advance, so the user does not need to set it up. So like a template. Features of report definition, a query, or a display order. So, wow, they're actually quite... Yeah, they've repeated themselves.
Yeah, it's not very good. Not very clear what they mean by that one.
And that's the end of that paper.
Right. Have we done this whole paper on the stream?
Yeah.
How long's the stream been going?
Stream's been going for about...
Hour and 15. Wow.
Yeah, and this is the plan for what I've got.
So is it a paper a day we do?
About 2 papers a day. Next stream is at 7 PM.
Alright, okay.
Do you want to be involved in the Skype call with that?
Yeah, I could be. That depends. I got an English exam tomorrow, so I'll probably be doing stuff for that. And then over the weekend, it'll be hard.
Yeah, so tomorrow I'll be at 4 PM. I'll do the June 2012, and Friday at 7 PM, January 2013, and then Saturday, might try and do it early in the morning or so, or I might just do it late at night instead. The June 2013, and I might do the June 2014. It depends.
June 2014, is that a thing?
Yeah, I've got that one.
How did you get that?
I will stop the stream now. Thanks for watching this video.